Welcome to Mandalay EF. You are here for the talk entitled Investigating DDoS, Architecture, Actors, and Attribution. Your speakers are Andre Correa and Elliot Peterson. But before they start, I have a couple of announcements. First, be sure to stop by the business hall located in Bayside AB. Also, don't forget the Black Hat Arsenal is on in the Palm Foyer on level 3, and of course the Arsenal reception at 1700 this evening. Very important, if you haven't picked up your merchandise, today is your last chance to visit the Black Hat Swag and Bookstore. Empty those pockets. Visit the Kali Linux Lab in Mandalay Bay, room A. And lastly, housekeeping. Thank you for putting your phone on vibrate, which is a nice way of saying, please put your phone on vibrate. So that way we can ignore the ringing, which won't be occurring because your phone will be on vibrate, while you wait for your voicemail to pick it up. Also, when we get to the question and answer part of the talk, if you would notice there are microphones in the aisles, be sure, are there? Look around and locate the microphone nearest you, keeping in mind that the nearest microphone may be behind you. There are not lights to illuminate the way to the microphone. Without further ado, Andre and Elliot.
Thanks, Ray. So thank you so much for being here. I'm Elliot. I work in the FBI's Anchorage office, and I'm joined by Andre, who's a co-founder of Malware Patrol. And we are two people that are really interested in DDoS. And so hopefully some of the people here are also interested in DDoS. And so we want to explain to you sort of what we have been studying, why we've been studying it, and then share with you some of the things we've learned that hopefully, if you're in a position where this stuff is disruptive or bothering you, we have some suggestions that maybe help with some of the mitigation, may shed some light on who and how you're getting attacked. We really would like questions, so we plan to leave some time at the end, and then to bribe you to ask questions, we've brought a couple different things to give away, just some little trinkets to give away if you're willing to step up there and ask us a question. So we're working as part of kind of a broader group that's really interested in this problem, the problem of DDoS, sort of where it's been recently and where we think it's headed. So we just wanted to recognize some of the other people that have been helping us out. It's really great to have the support of so many really talented engineers and researchers. So what we're going to talk through this morning is we're going to tell you just real briefly why we find DDoS so interesting. We're going to talk about maybe what we saw the last couple years, some things that have hit the news that you've probably all heard about and are familiar with. And then we're going to talk about what the landscape is now. So what we've seen, what we're studying, what are some of the tools, what are some of the techniques, what are some of the sort of groups that are really interested in DDoS and have created this marketplace that we kind of refer to as DDoS as a service. And we want to walk you through what that looks like. And then we're going to talk to you about some of the open source tools that we're using to study the problem. Because I think it's really fascinating to look at DDoS once you put yourself in a position to see the attacks at several different points. So we're going to talk to you about how we've done that and then some of what we've learned. We're going to talk through the DDoS as a service business model, just so maybe you're more familiar when you hear these concepts of booter, stressor, if you hear about an IoT botnet that's doing DDoS, what does that look like, how it's working? We're briefly going to touch on some of the legal definitions, just in terms of what I try to do in terms of investigation, like how do we fit DDoS into the broader concept of computer crime, what does that look like? And then we'd like to take questions from you to see if there's things that either you disagree with or you'd like us to expand on. So I got interested in DDoS relative to another investigation I'd worked on, a botnet known as Game Over Zeus, because the actors were actually using DDoS in conjunction with their fraud techniques, and they'd go and they would just hammer the login portal for a financial institution with these really large DDoS attacks, effectively precluding anybody from logging in. And that anybody they were really interested in was the victim. And the idea was if they could keep the victim from logging in for hours or days, they had enough time to get the funds out of the victim's account, have it posted in an international account, and then they're sending their mules in to pick up the funds. So it was really interesting to see the idea of DDoS being used in conjunction with all these other forms of crime and malware to affect this criminal fraud scheme. And so I really started paying close attention to it then, which is how I got introduced to sort of the broader group of people that look at this. And then following that, as I started to have conversations about, what does DDoS look like, who's it affecting, and I started to talk to engineers and architects at some of the different ISPs, it was brought to my attention that one of the things they were most worried about was the rise of this for-profit service that they were describing as booters, because they were telling me that they were getting more and more powerful. And so I thought that was interesting, and we started to talk numbers, and they explained to me that with a lot of ISPs, they use a hardware device known as an aggregator, where they're going to bundle a bunch of different customers behind that aggregator. So you could have 10,000 customers behind one aggregator. So, in a pretty big network block, you could have a /24 behind that. But a DDoS attack, that would fill the pipe for that aggregator. So the example they used, they said about 40 gigs a second was all it could handle. So if you could launch a DDoS attack at one IP behind that aggregator that could top above 40 gigabits per second, you could potentially cause an outage for every single person, up to 10,000 people behind that piece of hardware. And I thought that was really interesting because I'd never really considered the idea of the pipes being filled so far upstream that everybody downstream was being affected. And so that sort of led us to start jumping into taking a closer look at the problem.
Okay, hello, good morning, everybody. Nice to see so many people here, really big room. I would like to thank the folks from Black Hat for the opportunity, and Elliot for being here today, and all the other folks of our group. So as Elliot said, we are investigating DDoS activities, and I've been investigating this since September 2012, when we saw the first American banks being targeted. By that time, these banks weren't really prepared to deal with those attacks. So I've been investigating this and all the techniques and tactics and what's going on since then. So let's talk a little about what happened to DDoS in last few years, not going too far back in time, but in the last few years. So DDoS is really just preventing somebody from accessing a service, right? And during, since 2012, we saw this change in the techniques and tactics that they are using. So I was talking about American banks being targeted, and they were targeted by a botnet that was called the BroBot. And BroBot was a botnet made of servers that were hosting Joomla and WordPress instances. They were bridged, and scripts were uploaded to those. And those scripts allowed the attacker, which we later figured out was a group called QCF, to start attacks. And the interesting part of this is that those servers were hosted in service providers, so they were connected to high bandwidth networks. So they did, they created a lot of problems to American banks before they were able to put together all the mitigation strategies required to deal with the problem. Later, we saw a rise in the number of botnets that were made of Windows executables that were bots. So those bots were put on Windows machines using downloaders. And there were some families. One of the most well-known were Dirtjumper, Drive. They were very active. There are still botnets of those families, but they are very small these days. We were monitoring those botnets and saw a decline in probably late 2014 and 2015, a considerable decline in the amount of attacks done by those botnets. Right now we see mostly Russian sites and some obscure IP addresses being targeted by those. What happened is not that we didn't have any other attacks, but what happened is attackers figured out that maintaining botnets is time consuming, and they could do something easier, which is exploit services on the internet that allow to produce huge amounts of traffic, right? So we're talking about amplification and reflection. So I'm going to talk about this in a little bit. Another tool that is worth talking about is Loik. And Loik is a Windows tool that was used, for example, by groups like Anonymous to tell their to tell folks to run this tool and DDoS targets. So some of those campaigns that Anonymous did like OPE, the OPE, Israel, OPE, there are many operations, they use this tool. We saw as well some APTs, some campaigns against free democracy activists. So now Alex is going to talk about what's going on right now.
So what we're seeing now is a really heavy use of amplification and reflective attacks that are taking advantage of a lot of the UDP protocols. That seems to be the majority of the attacks that we see that a lot of our partners are seeing. We're seeing extensive use of what appears to be the booters and stressor services, and we're seeing a shift toward IoT and Linux-based botnets being used for DDoS attacks. And again, that seems to be growing quite a bit the last couple of years. The predominant attack types that we see actually utilized would be the HTTP floods, the SYN floods, and then the UDP protocols, the DNS, NTP, SSDTP, SNMP. And what Andre is going to do a little bit is just walk you through briefly what some of those protocols are and why they're being abused, and then sort of what we see in terms of data when attacks are launched with those protocols. Why is there such a heavy use of amplification and reflective? Well, it's the idea that if I send 1 byte to what we sometimes call a surface, a reflective or amplification surface, if I send 1 byte and I get 200 bytes in return, then that's a pretty good exchange for my time and bandwidth, with the additional benefit of sort of anonymizing the source of the attack because of the spoofing that's happening. So some great work that Christian Rosso has done and US CERT has published relates to some of the amplification factors. People get really excited about a potential amplification factor of 500. I would say practically, like, we're not really seeing exchanges on that level, but anything that's even amplifying 10, 20, 30 to 1, that's really interesting to the people that are putting together these attack tools, and it's definitely something that they're going to target. And we're actually seeing them, there's another business model that's sort of emerging, which is the idea of selling an amplifier list. So some people are very good at running DDoS for hire services, but they're not necessarily good at maintaining lists of good reflective surfaces. And so they'll farm out the job of scanning the internet and identifying these services and building these services. And there's usually a good chance that if you sit at a business, some of your services are sitting in some of these lists. And so a lot of times these lists are dumped. It's an easy thing to download, look for your own information and see if you're maybe contributing to part of these attacks. So briefly to talk about booters and stressors, and we're going to spend a little bit more time on these in a second. How we characterize these is they're really cheap. They're cheap to the scale of maybe $5 to $20 a month, with premium or more reliable or powerful services costing a little more than that. They like to take PayPal, Google, Bitcoin, although Damon McCoy and some other researchers have done an amazing job of working with some of those e-payment providers to push the booters out of that space. And so as a result, we've seen them start to use Bitcoin and Bitcoin-based payments a lot more frequently, which is interesting because we think there's a certain customer base that they probably lose when they do that, but they're still making money. The users don't need much or any technical experience. We see a lot of churn in terms of branding for the booters. So you might have one labeled front end that keeps cycling its name every few months, but the back end stays the same. Or similarly, you might have 5 different booter front ends that all are using the same underlying attack architecture. That's pretty common to see as well. And a lot of these services only last a few months. So they show up, they make some money, they advertise, and then they disappear. And so one of the things we've looked at is then it becomes really interesting to look at the ones that have been around for a while and figure out, well, why have they been successful? Why are they still in the marketplace? And the booting services are frequent targets. So I don't know that I've encountered one in the last few years that is not in and of itself sitting behind some enterprise DDoS protection, which is a little bit ironic, but because their competitors are attacking them. So they'll frequently attack each other's services as if to show that theirs is the better service. And then, we see them sort of bragging about these activities online.
Okay, so one of the things that we did during our research was to try to understand a little more how the architecture of the booters work. And we figured out some interesting things. First is booters usually reuse the same code for their front ends. So this is PHP code. And if you go to one booter and the other booter, you're going to see lots of similarities. So they change a little bit the design, but the interface is pretty much the same in what it can do, and its connections to billing systems like Elliot said, PayPal or Bitcoins and so. And also there is a backend, and the backend is I didn't see any that is not MySQL server. And the databases look all the same. So they are reusing the schema, the database schema as well. And so we have this communication of the front end, which is usually behind some kind of mitigation, DDoS mitigation system, contacting the backend, MySQL, and then they are using some types of APIs to contact the servers that are really doing the attacks. So the APIs are really simple, just HTTP requests that contain a key just known by the interface, the booter owner, and information about the target. So the host is going to be targeted, how long, and what's the protocol that's going to be used. So it's a very simple way to contact the servers that are going to start the attacks, and also they are able to grow servers, put new servers. So that's the way it works. Next one, please. Looking into the databases, there are lots of interesting information, but here I'm just showing how they put what they call shell posts or post shells or whatever that are those servers that start the attack. So you have these servers listed in the database, and that's how the front-end interface finds who's going to contact via the API. So just moving to our agenda, we said we were going to talk about booters and also the new trend we see, that is the usage of AOT devices and Linux boxes to create botnets, right? So you remember I said they have created botnets of Windows boxes, they move it to amplification attacks and reflection attacks, and now we see they move into creating botnets using those devices. So this is done by exploiting default passwords or vulnerabilities on those devices. There are many devices out there still with default passwords, and there are devices, for example, with bugs, like we had the zero-day bash bug in 2015 or 14 that was widely exploited. So here we have a little part of a code that they use when they break into one of these devices that is just, it's just meant to download the bot to the device and run the bot. So what they're trying here is to use tools that are usually available on those devices because they are Linux-based. So we're talking TFTP, BusyBox, wget, very common tools. They are trying to download a script that then will download binaries. And there are binaries compiled for multiple platforms because they don't know which platform the device uses, so ARM, 8086, and so on. Go ahead. All right, so talking about the research, we're going to show you some of the tools we have used and some of the results that we got with those tools. So starting in October 2014, we have deployed a network of honeypots. And this network of honeypots are very teeny sensors that are running or mimicking services that are usually exploited or abused by the attackers. So those services are UDP services. We're talking NTP, DNS, SSDP, ChargeN, and so on. The idea is to run those sensors in different networks and start collecting data about the attacks, right? So we are collecting things like timestamp, who was targeted, source and destination ports. With timestamps, we can see how long the attacks take, and we're also capturing PCAPs. An important thing to say is that the honey sensors are built in such a way that we just reply with the amount of data that is necessary for scanners to determine that that box is running a service that can be exploited. We don't reply with data that can be used in DDoS attacks. That's very important because we don't want to be part of DDoS attacks. The idea is that if we keep those honeypots running long enough, the guys creating amplification lists and running booters, we're going to scan the internet, we're going to find our service there, and we're going to put our IP addresses on those lists so we can start capturing attacks. Next one, please. So I have some numbers here. Starting this year, during 2016, we have captured something around 8 million records with this botnet. And as I said, we are capturing PCAPs and additional metadata, right? So the first challenge is how do we store and index and search and figure out what is inside all of this data. It's a lot of data when you have the PCAPs. So we did some research and found a tool that is very nice called Moloch. So Moloch is open source, and it works on top of Elastic Cache, and it does indexing of PCAPs. It can also do live capturing of PCAPs, but we are not doing this. We're just pushing the PCAPs from the sensors to the Moloch, kind of offline, just a few minutes later, and indexing. So very nice tool. You can see here a screenshot of it, and apart from being very quick indexing and showing information, it has a nice feature that allows you to query the data using a syntax that is very, very similar to what we commonly use on TCP dump and Wireshark. So you can filter by protocol, you can filter by port, IP address, ranges, stuff like this. And it shows, graphs and a map, and you can then filter the table here. You have additional information depending on the protocol. For example, if it's a DNS a query, you see the domain that's being queried. And you can even expand and see headers inside the PCAP, IP address IP headers, and so on. So very interesting tool. It's been very helpful. Moving ahead to results. So we brought here results for July 2016. During this month, we saw 30,000 IP addresses being targeted. And you may remember Elliot showed you a table with the amplification factors. And there you saw that NTP and charge-in were the top ones, right? But here we have the statistics showing that they were using more SSDP. So SSDP, not sure if everybody knows about it. It's a simple service discovery protocol, kind of obscure. And it's been, the top one used. And we believe that NTP is not that heavily used anymore because of the campaign that was done to patch NTP servers that were vulnerable. Actually, those servers they had a command called monlist that when it was called, it was meant to return a list of the clients that queried that server before. So attackers were exploiting that functionality. And this functionality is not very frequently used, not used at all, I guess. So the new patches don't allow that functionality to be exploited anymore. Next one. So talking about the protocols, so SSDP top one, we got the 3 top most attacked ASNs. Next one. And then you see, this is a packet that was captured from a live attack. So you see the reply, and it's a very regular SSDP reply. So one of the things that we want to figure out when we dive into all the PCAPs is if there's something interesting we can tell you guys about this traffic that can allow you to filter or figure out you're being targeted by a booter, for example, or by a specific botnet, right? Here, there is nothing very interesting that can allow you to filter this traffic other than you probably don't want SSDP traffic coming into your network. Usually that's not what you want. Next one. Next protocol, NTP. So NTP is interesting because the second one we saw in the statistic is 1.1.1.1, which is not a target, right? Nobody's targeting this IP address. So I personally believe that there's some tool out there being distributed that had this IP address hard-coded, or there's a bug or something, because it's very unexpected, really. Next one. So here are, this is a PCAP of one, we got from one of the sensors. Next one, please. So you can see that it's using NTP version 2, and it's doing the monlist command. So yeah, it's also this is the request, right? So this is a spoofed request coming from the attacker. It's sending a spoof request to a vulnerable NTP server, which doesn't know it's a spoof, so it's going to send the response, which is much bigger than the request, so there's the amplification factor, and it's sending this to the victim, right? Another one, DNS. So DNS is interesting because if you're trying to use DNS to create an amplified attack, you're looking for zones that have records that are much bigger than your request, right? And those zones usually have ANY and TXT records that are very big. We usually put, for example, on TXT, we put DNSSEC record information, right? So these guys are targeting ANY and TXT and domains that have large zones. In the past, during 2015, most of the year, we saw many domains that were registered solely for the purpose of creating very large DNS records. Right now, July 2016, we didn't see those domains here anymore. So all of them here, the top ones are legitimate domains. And they include two .gov domains, so CPSC and IRS. They have very large zones. There's also DEF CON there. So important to say, there's nothing wrong with these domains. There's nothing wrong with their DNS zones or DNS configuration. That's the way it is. They have big DNS records. They have been exploited. There isn't much we can do about it. Next one, please. So here's a PCAP of a reply, right? We got this one from a live attack test. And it's just a reply for cpsc.org. You can see, next one, down there's a 4K something reply. So it's a good amplification factor for your ordinary DNS query. Another one, charging. So surprisingly, we still see charging servers open to the internet. So if you guys don't know, charging is a very old protocol that was just supposed to throw a sequence of characters for you to test connections. Nobody's using this these days, so there shouldn't be any charging servers open, but there are. So here we have, again, a regular charging response. You can see at the bottom just the sequence of characters. This is, again, from a live attack. Go ahead. SNMP, so again, down here is just a reply, a snippet of a reply, a regular SNMP response with a community. I think we're going to see more SNMP being exploited in the future, but it's not the most exploited right now. Other protocols that have been used. So I was talking about UDP, I was talking about spoofing, right? So reflection, but booters are also sometimes offering HTTP attacks. And this is a very interesting opportunity because HTTP GET requests are not spoofed, so we get to know the real IP addresses of the servers that are being used, right? So we have GET, POST, and HEAD most of the time, the three of them. And if you're an attacker, you're looking to target URLs that consume lots of resources. So you're probably looking for URLs that require database queries or start a large download. So again, a PCAP of a live attack, it's just a regular HTTP request, so coming from the booter to a target. One interesting thing just there is if you're thinking about protecting yourself, you could consider filtering by user agents, but most of the booters, not to say them all, usually randomize the user agents, so they use ordinary user agents. There isn't much you can do there to filter the traffic. Apart from using UDP to exploit these services and protocols, they also offer UDP floods. So this is just, to fuel somebody's pipe to the internet and doesn't, not allow any traffic to the victim, right? And they don't even care to target any open ports. For example, here is a live PCAP, and they're doing a UDP flood, so source IP addresses are all spoofed. And you have the destination port 80. There's nothing most of the time or all the time listening on port 80 UDP, right? And also, if you're considering filtering by source port. This time they set the source ports randomly. Yeah,
So one of the more interesting things we've been doing as part of the research is actually going out and doing attack testing of these tools and techniques. And we did a lot of work on the front end to make sure we could do that legally and properly with minimal risk to people and infrastructure. So we went and found targets, we talked to ISPs, we found a way to make sure that we were going to be able to deliver the packets safely because, as I'll show you in a little bit, these services say they can hit really hard and really big. And so we wanted to avoid the problems that I described earlier where we could have sort of unintended consequences as the result of triggering some of these tests. But we also thought it was going to be really important to validate what they're doing and what they're doing relative to the claims they make. And so what I wanted to do is just sort of summarize. I mean, I bet we've done probably 8, 10 different iterations at this point of attack testing. And we've seen some really interesting things relative to what they say they do, what they say to deliver, and what actually shows up at the victim end. So to begin with, it's a lot of these booting services or DDoS for hire services. They're a great, slick web front end that works really well at taking your money and then doesn't actually attack. And so we ran into several times where we'd go sign up for some of these services, click attack, and nothing would happen. And then we'd figure out there was actually no fundamental back end to exercise these attacks. They were just sort of trying to jump on the money train of all the people that are interested in DDoS services. As I'll show you a little bit in the forums, they all say they can do a million different attack types. I mean, anytime something makes the news or there's this new attack type or something that might beat sort of the enterprise DDoS protection, they all say they do it. Well, when we go out and actually test those attacks, when they do deliver attack according to that attack type, it's usually not that new attack type. It's usually still just an NTP or DNS or some form of UDP flooding, which we thought was really interesting. And then another thing that we've noticed that's really interesting is that even if I'm using an attack type for a specific attack service that works, so this specific DDoS service does a really good job with NTP, it could be 1 out of every 4 times it doesn't function, and we think that may relate to either the overall bandwidth of the number of users using the service or that they have a rotating array of attack servers and one of them is just not functioning anymore. So that was something that we saw that was pretty interesting. And then I think one of the big takeaways for anyone that's a defender is in terms of the testing that we've done with the booter services, with the for hire services, we have never been able to see at the victim end more than 30 gigs delivered. And we have seen 30 gigs delivered, which in and of itself is a very significant, very large attack. But we have never seen these 200-300 gig attacks. And talking to sort of the broader group of the people that study this, that's pretty consistent. And in fact, most of our testing showed attacks anywhere in the 1 gig to 10 gig range with many attacks that were perfectly functional, which would absolutely knock you offline, that were much less than that because most of us don't have 1 gig connections. So anything, 10 meg connection that is using the right attack type is usually enough to knock a lot of people offline or disrupt their connection to the extent that whatever they're doing becomes unavailable. So that was pretty interesting. We usually saw the highest overall bandwidth initially. That probably makes sense to you. So the peak bandwidth was usually the highest bandwidth. But interestingly, the bandwidth would usually rapidly drop off. So even if we said, I want a 10-minute attack, we might have a good minute or two where all the sort of, the reflective, all the amplification stuff was rolling in. And then right after that, it would get really, really quiet. And sometimes you'd ask for a 10-minute attack and you'd get the same duration you got with anything. So despite the idea that some of these services say you can attack for hours, a lot of them just give you 1 or 2 scripted minutes of attack and then they stop. So what I want to do now is, because you've been listening to us for over 30 minutes and some of you are probably ready for us to be done talking and you're thinking, gosh, I wish I could go hire one of these services and knock these guys offline. So I'm going to walk you through how you would do that. And we're going to go to a wonderful place called Hack Forums, and we're going to go into their marketplace, and then we're going to go to their server stress testing forum, where there are page upon page upon page of these products. And you'll notice, interestingly enough, I think that they all advertise themselves the same way. So you're never going to find a service anymore that doesn't claim to deliver at least 200 gigs, which none of them are doing, but they all say 200, 300. I mean, as soon as somebody publishes and say they saw a 500 gig attack in the wild, someone's going to take credit, and that's going to be the new standard they all claim they can do. They all say they can do all of the attack testing, or all the attack types you've ever seen. They all say they offer API support, although functionally a lot of that's broken for most of these services. And then a lot of them offer VIP services, which is a really interesting concept I'll talk about in a second. So you have a choice. We can go look at top seller or best deal, We're going to go to top seller. And you're going to learn at this top seller, this wonderful service, they offer 100% uptime, a dedicated support team, which is actually true. A lot of these services have really good support teams. VIP network, API, layer 4 and 7, instant setup, IP geolocation, which as best we can tell, they're just saying they'll resolve a domain for you so you can actually attack the right place, and a dynamic boot hub. So to talk about the VIP network briefly, VIP is the concept that like this service and whatever packets it delivers is not enough for you. You are a premium customer. You don't want to share a service with other people. You want a bigger attack. You want to pay a lot of money. And so all of these services anymore seem to offer the VIP, where you pay 5 times as much, 10 times as much as a standard equipment, as a standard user. They guarantee higher bandwidth. They guarantee less users. They often will guarantee concurrent attacks, which is this really interesting concept because most of these APIs only support 1 attack per user. And there are customers out there that want to pay to have the ability to knock multiple IPs offline simultaneously, which we find to be pretty interesting. So, you know, VIP is really starting to jump up into a really interesting price range, and we've seen some priced as high as $200 a month. And looking at different services, we'll see almost as many base subscriptions as VIP subscriptions, which I find a little bit troubling. So just for example, for this service, $10 to $50, the only difference in this case is attack duration. And even that, you're not likely to get the delivered attack duration. What you'll see sometimes with some services is the attack types you're allowed will grow, the bandwidth allegedly will grow as you move yourself up in the pricing scheme. And this service can take down home connections, protected servers, websites, and game servers, and much more. We have yet to figure out what much more represents, because this seems to be most of the internet. So now all of you right now are this, right? You want to see this work. So we're going to take you into another one. And what happens, you go to one of these web pages, you get a nice front end that has you log in. When you log in, you end up at a landing page, all right? And the landing page is a bunch of stats that usually are mostly bogus, that tells you how good they're doing, how many attacks people are running. You know, this is a really strong booter. You walk into the attack portal, and all you need to do is give them an IP, a port number, and a duration of the attack. Almost always that's just in seconds. And then you literally just click this little green button, and then this service is going to tell you, you did a good job, you just took something down, which has no representation to whether or not that actually happened, which is why we've done a lot of the testing that we've done. So one of the other things we've seen in conjunction with this is something we're starting to call like a turnkey DDoS service, right? So maybe this booting service wasn't powerful enough or wasn't enough for you, or maybe the VIP service wasn't enough. You need your own dedicated service, and there's starting to be this cottage industry growing around providing you your own server, and they're going to give you attack scripts, they're going to give you an API that functions, and they're going to give you your own built-in amplifier lists, and that's all going to be preloaded on the server that's sitting at an ISP that allows IP header spoofing. That's an important distinction. That's where a lot of these attacks are actually emanating from. And you're going to pay a lot. This is a pretty premium service that people are jumping for, and you're going to get dedicated customer service. And from what we've seen, you actually get pretty decent customer service, which leads to the question, I think a really important question, who's doing this? Because one of the things I get asked a lot when you know, my background in a lot of this investigation has been botnets, which is often very Eastern European focused, and a lot of people just think of like cybercrime as, okay, that's an Eastern European problem. Well, in this instant, I have yet to encounter a booter or stressor service, or these DDoS for hire services that are not North American, Western Europe, or based in Israel, which I think is really fascinating. That is 100% where all the guys running these services are sitting at. And the age is interesting because we see them pretty young, I mean down to 16, 17, but by the time they really have a functional service that's running, that's been up for a while, they're starting to make a lot of money. They're now in the 18, 19, you know, mid-20s range. And they have a support team, so we'll see usually 2 primary guys that might sit on the forum. So I showed you that Hack Forums post, and they'll sit there with their nickname, which is often the same nickname they're using on Skype and the same nickname that they're using on Twitter. And I tell you that because if you're trying to figure out from a threat intel perspective who's targeting you, figuring out the service or figuring out who on Twitter is claiming credit for it, and taking that nick down to Hack Forums, or there's ways for you to sort of traverse the world these guys operate in and get a better sense of who's interested in your company and who's interested in attacking you and what some of their capabilities are. And somewhat, I think, because of how they get exposed to DDoS and how they become interested in DDoS, they're very heavy users of social media. These guys have a really, really big footprint, and it's not necessarily that difficult to figure out who they are, where they're from. So this little Twitter feed down here is one of the guys that was running a service. From his Twitter handle and his real name, he was posting, I mean, he probably had a holiday coming up and needed money, but a vastly discounted rate for his service. So there's a lot of sort of OPSEC decisions made by these groups that are really surprising, but I think that one of the benefits to you as a defender is you can actually get more information about who's coming after you with DDoS than you'd expect. And so, you know, we've walked you through the sensors, and a little bit we want to tie this all together and sort of explain, like, how do you really get a better idea of what your kind of attack surface is? So one of the really great ways, again, from a defender standpoint, to figure out who's interested in you is pull down some of the databases that have been leaked. It's very common for the back ends for these DDoS services to be leaked because they like to hack each other, or the service goes under, or they dump in their database to pay spin without realizing that's going to cause them problems. But you can go in there, you can pull down the entire database, you can go in and search for IPs that correspond to you or things you're interested in. When you have that IP, you can then figure out which user launched the attack, and then you go to the user table and you go look at that user's identifying information, and very likely that email they gave you is going to have a Skype handle tied to it, and you can start to get into the world of who is interested in my company and maybe why are they attacking me, which we found really, really interesting to look at. So really briefly, I wanted to talk about how DDoS kind of fits in this concept of the law. And in the US, we use the computer crime, computer fraud statute. And the idea is violating that requires someone to knowingly cause the transmission of a program, information, code, or command, which results in or intentionally causes damage without authorization to a protected computer. That may make sense to all of you. It can be a difficult thing to work through. So cause the transmission, I think generally, yes, that's pretty easy to understand. Is a DDoS attack code, command, information? It can fit in all of those things, but generally when we look at if their intent is to fill a pipe, we like to fit within the information definition. Causes damage, an accepted legal definition of causes damage is reducing the connectivity. So if I reduce or degrade or limit the connectivity of a protected computer, which we understand to basically be any computer out there that somebody is lawfully using, if I make it so that computer can't connect to the internet or an essential service anymore, then I've likely violated the statute. And then to kick it up to the felony, we've got to hit 5,000 or more in damage to a single user or 10 or more damaged computers. So it's interesting, and I think it's easy to understand, but then taking the pieces of what they're doing or what these actors are doing and fitting it within that definition, I have found to be a really interesting problem. And so I've really enjoyed being able to work with engineers and architects to try to find ways to show this is happening. And I just want to contrast this briefly with the United Kingdom, which has in some ways a cleaner definition that the NCA and Met have used successfully a lot of times the last couple of years to target some of these DDoS services. And that's simply, they say, unauthorized acts with the intent to impair the operation of a computer. So if you know it's going to hurt a computer and you do it anyway, that's bad, that's against the law, and that's pretty much the definition of what people are trying to accomplish with DDoS. And a really great Twitter post I came across yesterday in reference to some of the attacks that are going on right now in the last couple of days was that there needs to be a law where hacking and DDoSing a company puts you in jail. And I agree. And there's this perception in the industry that, and even among the guys operating this, that it's okay. And we don't agree with that. We think that that's wrong, but we think that perception is sort of feeding this marketplace. And it seems a little concerning that you've got guys growing up where from the age 14 on, they've had access to really powerful DDoS tools, and they get used to using it whenever somebody irritates them online. And that somebody could be a school or municipal services or a lot of these things that start to be a lot more vulnerable to this kind of disruption. So what we want you to hear in terms of what you think about a network defender related to where we see DDoS going is that duration matters. When you're studying attacks that are hitting you, a shorter attack is often a booting service. You know, the botnets can be used kind of surgically, but usually those are longer running attacks, more powerful attacks. So if you're seeing a lot of kind of shorter running attacks, that could very well be a booting service. As I told you before, we haven't really seen those get above 30 gigs measured at the victim. If you've seen more, we find that interesting. We'd just love to know kind of how you're measuring that. The packets that you receive as part of the attack can be interesting because they can tell you potentially a lot about the attacker or the attack tools based on what you actually have coming in. And we think that the packets plus the sensors, so the idea now with a sensor that you're actually seeing the attack as they run. You don't depend on being able to capture those at the victim end. The sensors can be really valuable. And the generally accepted threshold for sensors is about 20 distributed DDoS sensors of some of the more common application types. About 20 of those sensors laid out will get you better than 80, 90% visibility for those specific protocols around the world, which is pretty significant. We think you should look at social media. We think you should pay attention to what's going on at work, whether employees are gaming, that can cause problems. You may see attacks coming in, and you may inadvertently be participating in this mess by having servers misconfigured. And we think that the enterprise DDoS mitigation solutions work because these services will actually say they can't beat it. So what we want to do now is take questions. We're hoping that some of you have some questions about the work we've been doing. So if you want to just run up to one of the microphones, we'd love to hear what you've got to say.
Are you guys seeing, in terms of percentages, the upswing in DDoS over the last couple of years? Do you have any numbers on that?
Yeah, I would say yes. I think we've seen them coming more with certain protocols and doing more targeting. I don't think that that's been a focus in terms of quantity, but I would absolutely say that it seems like it's increasing. And the awareness in certain communities of how easy it is to do these seems to be increasing.
What would you say is the frequency of layer 7 type attacks as opposed to, more classic layer 3 attacks, and what's that trending?
So I don't have specific numbers, but what I can tell you is that most of the booter services are not offering layer 7 attacks, mostly because those will expose IP addresses. So I would say the majority of the attacks is, are using UDP protocol, not HTTP. And during our tests, we saw some of those booters offering HTTP attacks. And in fact, what we got was just symfloods. So just, random source IP addresses and symfloods, not really HTTP requests. So they're kind of rare.
Question here. So you guys saw about 30 gigabits a second attack traffic, yet we do know of attacks that are 300 gigabits and so.
Absolutely.
So do you think that you guys are just seeing the lower end of a market and there exists a premium market, or do you think that that 300 gigabit market is part of organized crime or nation state attackers?
Yeah, so really good question. I would say that I think if we spent more time in the premium market, we would probably see attacks hit 40 to 50 gigs. I think how you measure those attacks become important. And while we do see 200-300 gigs attack, and while some of our partners that do DDoS enterprise mitigation do see those size of attacks, they're a lot more uncommon than people think. And they often seem to be attributed to botnets, Linux-based botnets, things that have a lot more throughput from what we've seen. But I think there's a lot of question in terms of how those are really being measured and if the measurements are often accurate. But great question. We're still trying to solve some of that.
I have two questions.
Thank you.
Number one is BCP 38, which is supposed to be filed by the ISPs. Many of them are not following them, including in Northern Europe and also the US. This is actually a source of why spoofing even occurs. Have you taken any action to convince these major providers to actually mitigate this particular issue by going to them to mitigate this spoofing?
That's a great question. Yeah. We haven't on our end. There are people doing that and trying to tighten that up, but that is not something we've tried to do. But absolutely, that will fix a good portion of this.
This is a known 20-year issue. You guys haven't taken
Yeah,
action.
it is. And some of the problems that some ISPs are pointing to not adopt BCP 38 are not real. So there are options for you when you are doing BGP or you're doing multi-home BGP as well, right? So yeah, this is a must-do for ISPs, and we believe that if most of the ISPs would do that, we would have a reduction in the amount of floods that are using, UDP and spoofed packages, definitely. So we're totally in favor of BCP 38 and its adoption.
Second issue is we've actually seen some IPv6 specific, but I noticed the tools you're using are IPv4 only
Sure.
at this point.
Yeah, it's not something I've spent a lot of time. I mean, most of the people we're dealing with are still sitting IPv4. If we see an uptick or I start seeing victims that are having a problem with that on that range, we'll look at it, but we haven't been.
Thank you.
Thank you.
Hi there, over here. So my question is in regard to, aside from these, smaller services, a more organized attack from a larger team, such as in a cyber warfare context, is there any research that's been done on those situations? Any suggested books or reading that I could get my hands on in this context?
Yeah, it's a great question. It's something, honestly, that I want to get into studying next because I don't think it's well understood what DDoS at scale really looks like. So, a lot of people talk about it in vague details. There's very few instances of, there's not a lot of companies that have data on that. When they have it, they've been sort of not excited to publish it or talk about it. But I think you're going to see in the next couple of years a lot more of that sort of nation state DDoS.
Thank you.
Yeah, I just wanted to say something about the other question. The guy was talking about IPv6, and I was trying to remember here if I saw any booter services offering DDoS attacks to IPv6 addresses, and I don't think so. So I don't think there are, at least most of the booters are not offering access to, DDoS IPv6 addresses right now.
I think we can take one more. If you've asked a question, come run us down. We'll give you some patches and stuff. And otherwise, if there's something you really still want to know, we'll go hang out back afterwards so you can ask us. So one more, please.
Do you have any? About using honeypots, I think earlier. I know it's a very old method of identifying some fingerprints, but have you, thought about taking it further, using some level of automation, using those fingerprints to automatically prevent your production or any of those secure environment?
Okay, I didn't get all of it, but I think you were asking us if we've used like honeypots to do some attack fingerprinting possibly?
Right, and using those fingerprints to proactively prevent.
Yeah, great question. So there's a group about to release some research on that. If you look, Christian Rosso is part of that. They think they found a way from attack fingerprints on the victim end with their data as sensors to actually ID specific services. It's a really interesting problem they think they found at least a solution to, and they're going to be releasing some information on that soon.
Cool, thank you.
Yep. Thank you guys so much.
Thank you very much.
Hi. Yeah.